Well, hello there once again. It is KP the Math G. We've been doing some derivatives lately, having a lot of fun with it, and we're going to do a two-part video on the chain rule, namely because we need to familiarize ourselves with the chain rule in part one and then do a few of the more difficult problems like a combination of product and chain rule, or maybe a quotient rule and the chain rule. You get what I'm talking about. So we're just going to try to give you the basic idea behind the chain rule. Well, let's talk a little bit about this. If let's just get the general idea. If y is equal to f, and then there's some kind of function in here, g at x. That's a composite function, isn't it? You're familiar with that. Alright, well then, well, let's see, let's go ahead and put it over here. Y prime is equal to, now take the derivative of, this is the outside, this is the inside. So take the derivative of the outside, do nothing to the inside as of yet, and then times the derivative of the inside. So, okay, outside, inside. Okay, do the outside first, then the inside. Never the other way around. Never, ever. Okay. Alright, and that's just the general idea behind doing the chain rule. Well, let's see. There are some things that require the chain rule, and sometimes there is and sometimes there isn't. I'm going to do one problem where you don't have to use the chain rule, but you can use the chain rule. Either way, you're going to get the same answer. And all right, let's start. Let's make y equals, so let's say if y is equal to sine of 2x, then let's find y prime. That means we're going to take the derivative of this. But now we can rewrite sine 2x. There is an identity for that, of this double angle. So let's see, let's rewrite it. So first of all, this is without the chain rule. We can just simply say, well, this is 2 sine x cosine x. Keep in mind, that's times, isn't it? Alright, now that is a strict product rule, isn't it? So here we can perform the product rule. Alright, product rule. Alright, so remember that is the, if we say y prime or something, that is, and we got a and b, we can do a times the derivative of b plus, and then you can take the derivative of a times b like that if you want to do it that way. A being, in this case, sine x, and b being cosine x. Alright, so let's, or actually a is 2 sine x rather. Alright, so let's do this. Let's follow this pattern here. Alright, and I could have done it the other way. I could say the derivative first times the second, and so on, and just do it that way. Well, we're going to go ahead and do this. So then let's say y prime is a, alright, there it is, times the derivative of b. Anybody remember what the derivative of cosine is? Well, it is negative sine. Alright, negative sine. Alright, there we go. Plus the derivative of 2 sine x, which is just 2 cosine x. Alright, and then times b, which is just cosine x. Alright, we can clean this up a little bit, so let's do that. So this equals 2 sine times sine is, oh, let's make it negative 2. How about that? Because we already have a negative sign right here. Okay, so negative, all this is multiplied anyway, so negative 2 sine squared x. Alright. And then plus 2 cosine squared x. Alright. And let's see if I can, okay. We probably could leave it like that. Some people decide that I think that's correct. Okay, so let's see, let's turn this around. I like to, if I have a negative in front, I can put the negative on the end. Okay, so let's see what we get here. So 2, and I wrote this out before. Alright, I'm going to make sure that I've done my derivative correctly in the first place. Alright, so let's see, the first times the derivative of the second, cool, good, plus the a. Alright, so let's see, yeah, the derivative of the first, that's 2 cosine x, that's it there, no problem there, and then times this one. Okay, so everything looks good. One thing we could do, all I remember, I just did, this is a plus b, this is now b plus negative a. Okay, so if you want to do it that way. Alright, I still have everything where it belongs. We could take out a 2. Alright, so we have a 2, and then we have cosine squared x minus sine squared x. And I want to say that this is a, what can I say it is? It's an identity. Alright, so I want to say that that's an identity of 2, let's see, I want to say that it is cosine squared, oh no, I'm sorry, that's wrong, that is not right. Cosine squared minus sine squared is just, the 2 is part of it. We'll just go ahead and separate that if you want. This part right here is just cosine 2x. Alright, this is an identity. Cosine squared minus sine squared is just cosine 2x. So actually we just have 2 cosine 2x. Alright, so that, just remember that is the derivative, doing it by the product rule. We probably could have done better by switching this around, but this is okay too. I wanted to do it this way because I knew that there would be an identity hidden in this. So, yeah, that's the way I wanted to do that. And just remember that there is sine squared plus cosine squared, which is 1, but cosine squared minus sine squared is cosine 2x. Okay. Alright. That is it. Okay. In this case, 2 cosine 2x. So let's write it up here. y prime is equal to 2 cosine 2x. Now, I'll tell you what, let's do. Let's leave that there, and let's erase this. Let's do it again, but this time we're going to do the chain rule. Okay? So let's go ahead and do that. It's a pretty cool deal here. I thought I had to break that down into that thing. That just goes to tell you that when you're taking calculus courses, you've got to go back to your identities, and oh boy, I got to memorize some of those identities again. Okay, I had memorized that sine 2x is 2 sine x cosine x, and also cosine squared x minus sine squared x is 2 cosine 2. Well, in this case, it's cosine 2x. Alright, the 2's just stuck out there. Okay, here we go. Let's erase this down. And hopefully when we do the chain rule, which by the way is a little bit faster than this one, we can get this exact same answer. Alright, that's the idea anyway, isn't it? Okay. Alright. Alright. Alright, here we go. Let's erase this too. We don't need that anymore. After a little while, my board started squeaking here, so I don't know what's. Anyway, it's getting erased, so that's doesn't matter if it squeaks, I guess. Anyway, guess not. All right, so here we go. All right, so let's now find y prime, and let's do it by the chain rule. It's going to be a whole lot quicker. So now y prime. Here's our original problem, right there. Now, remember, you don't do the derivative of 2x first. Let's put that in parentheses. Do the derivative of sine first, which, by the way, y prime equals cosine 2x. Now take the derivative of the inner part. So this is the outer part, and this is the inner part. Okay, so we took the derivative of sine, leave the 2x alone. Now the derivative of 2x, which is just 2. Alright, and then of course now we can put the 2 in front, so this equals 2 cosine 2x. Wow, that was a lot quicker than the other way. But now I'll just say this. In calculus, if you cannot remember this, which I hope you do, because it's good to know that, okay? But in case you forgot, if you know the identity to sine 2x, then we can do the product rule and get the exact same answer. And sometimes you need to know that there's more than one way to do this. Okay, so we got this in 2 ways. Sometimes you don't have 2 ways to do something. You only have one. Alright, so I'm going to give you another problem. Okay, so let's go with this one. Alright. I notice it did match here. Alright, okay. Alright. Alright, so let's go ahead and erase this. Well, erasing takes up time, but that's okay. All I've got is a little bit of time. I'll be out, I have a garden outside, and I'll be out in that soon enough. Well, actually a greenhouse. I'm going to be looking inside the greenhouse. I've got to work on it a little bit. Anyway. So, but I got this to do now. So, all right. Let's say we've got y is equal to, alright, and we're going to do a square root this time. Let's say we got y is equal to the square root of x cubed plus 20. And if you want to, we could do 20x. That's alright. There we go. Let's do it. Alright, now this is a square root. Now remember, when we're taking derivatives of this, a square root or a cube root or a fourth root and so on, let's write it as an exponent. And what we're going to do, we're going to have a combination of the power rule and the chain rule. Alright, so here we go. We got y, rewriting it as x cubed plus 20x. We're going to raise it. Now this is understood to be 2 and this is understood to be 1. And remember now that is the exponent. This is the index. You will never see the 2 there. It's just understood to be there. Square roots. That's the way it is. So we're going to write it as 1/2. It can be written as an exponent. Alright. And the same can be said that if I have y is equal to x to the 1/3, oh, well, that's actually the, well, that is, I already gave it away. If I have the cube root of x, this is x to the 1/3. Y is equal to the fourth root of x. I have x to the 1/4. And if I want to do something like this, y is equal to the fourth root of x cubed, then I still write it as x. Here's the exponent, and here's the index. So x to the, write it again, x to the 3/4. Okay, so you get the idea behind this. And we're probably going to do another problem that deals with that, but we're going to reserve that for another lesson. Okay, so let's go ahead and do this. Okay, now, the first thing to do in the derivative, oh, I got the y prime. Okay, so the first thing to do is take your exponent and put it in front and do nothing to this at all. So again, oh yeah, we have to put it in front. We have to rewrite our problem, x cubed plus 20x. Alright, now what we do, remember when you do the power rule, you got to subtract 1 from that. So 1/2 minus 1 is the same as 1/2 minus, and let's just get a common denominator. If this is going to be if this is a 2, I'm going to make that denominator 2. So 2 over 2. If this had been 1/3 minus 1, I would have said 1/3 minus, well, let's make this a 3, and we'll make this a 3. 3 over 3 is 1. So you can do it that way. So anyway, that's an idea to keep in mind when you're doing this. Well, we got to remember this is 1 minus 1/2, which is in, by the way, it's negative 1/2, isn't it? 1/2 minus 2 over 2 rather is negative 1 over 2. Just subtract the numerators. You got 1 minus 2 is negative 1, and keep the 2. So this is now to the negative 1/2. Hopefully you get where you can just do this automatically here. Okay. Alright, now what's left is I need to take the derivative of all this. I'm just going to put the prime there to show that I've got to do the derivative here. This part right here is done, by the way. I just need to do this now. Okay, so here we go. This is equal to 1/2. Alright, so x cubed plus 20x to the negative 1/2 times, now the derivative of this. Put the next exponent, this is the power rule, so 3x, and remember this is reduced by 1, and then this is just, remember if you have an x, that's just the number itself, so that's just plus 20 right there. Okay, and basically that is it. We can rewrite this one other way. If you have a negative exponent, remember all of this, by the way, is over 1 if you want to do it that way. So you already got 2. Let's see if we move this like this, 1/2. Alright. 1 to 2 is down here, isn't it? Alright, so, alright, and then, of course, this being a negative exponent, we move this down. This is a exponent of 1. It's positive, so it stays up. Okay, so we can rewrite this. So this is equal to, alright, so let's see. Let's make our denominator here. And I don't need that 1 there. Okay, let's put our 2 down here. That belongs down there. This belongs down here with a positive exponent. And that's to the positive 1/2. Remember, if we have n to the negative m, when we put it down, it's n to the positive m, like that. I remember so many math rules, don't you? Alright, so there we go. We move this down. This stays up because this has a positive exponent. So we have now 3x squared plus 20x up here. And we can write this one final way, because remember that we just said a while ago that if you have something to the 1/2 rule, that's the same thing as the square root. So we can put the square root symbol there. So let's see. 3x squared plus 20x all over 2 times the square root of x to the 3rd plus 20. Alright, I do believe, oh, that was an x, wasn't it? Yep, that was an x. I knew it. Alright. Sometimes I just wish somebody would shout through the camera and say, hey, you forgot your x. KP the math G. Well, we got it back. Making sure this is not an x. Oh my goodness, please. There we go. Oh. There's not an x here. I don't know why I put that. I just did. Okay. There we go. Because see, when we took the derivative of 20x, it is just 20. Okay. Alright, there it is. Everything's right now. Well, you have to double check your work, don't you? That just goes to show you that no matter how much advanced you might be, you have to look over your work, or you will overlook your work. So always keep that in mind. And we did everything correct, so everything's good. Alright, so that is how you do that particular problem. I want to end with one more that's kind of like that. So, alright, one more time. Pretty good problem there, wasn't it? Alright. What we can do to save time. Let's save ourselves a little time here. I'll just flip this board over and we don't have to worry about erasing. Alright, grandson, you're fixing to be flipped upside down. Hold it. Ah, there we go. That's so much quicker. Well, alright. One more time. Let's do that same principle, except with no square root. Let's just make it 1 over, here we go, 4x squared plus 5x minus 8 raised to the 5th power. So this is going to be over, okay. Now I want to find y prime. So find y prime. Well, let's rewrite it without the y. Well, we want to find y prime. Y can be rewritten as 4x squared plus 5x minus 8. And remember, if the exponent is positive, if you move it to the numerator, which by the way, it's a 1 if you move it. So I'm moving this up. That's going to make this a negative 5. Okay. If you have a denominator like this, you want to move it up and make, or well, if it's negative, you can move it up and make it positive. But if it's positive, you move it up and it's negative. So, okay, in this case, it's negative 5. So that's what we're doing. We're going to take the derivative of this, which is really this. All right. In other words, 1 over a to the positive n, all right, is equal to a to the negative n. All right, and that's what we got here. All right, so here we go. Y prime of this. Now remember, we're just going to say negative 5. We're going to move that exponent in front like this, and times 4x squared plus 5x minus 8. We're not taking the derivative of the inside yet. That's what the chain rule is all about. But we do need to subtract 1 from this. It's not going to be negative 4. It's going to be negative 6. Subtract 1. Always remember to do that. Okay. We'll worry about this later. But now we got to take the derivative. We got to take the derivative of that. So we cannot forget that. So first of all, you take care of the exponent. Do not do anything to that. And that's the same way we did with the 1/2. Okay. And then we got to take the derivative of this. So let's do this part. This part's done. So here we go. This is negative 5 times 4x squared plus 5x minus 8. Now times. Alright, now let's do the derivative of this. 2 times 4 is 8. 8x. Remember, that's to the 1 power. Alright, we subtract the exponent. Remember, if you just have the 5x, that's just plus 5. And remember that the derivative, and I put the parentheses around a little too soon, because the derivative, this has a derivative, but it is 0. I want you to get that. But again, 5 minus 0 is just simply 5. So we could have just closed it off like that. So constant, don't worry about. Okay, the derivative of that is 0. Now, oh yeah, I forgot to put the negative 6 up here. There we go. Now remember, this negative 5 is not an exponent, so it's part of this. This is all, you know, part of the numerator right here. This is to the 1 power. All of that is to the 1. So that stays up here. This is the only thing that moves down. So we can rewrite this as negative 5 times 8x plus 5 all over. Now when we bring this down, this is 4x squared plus 5x minus 8 raised to the positive 6th power. And there we go. And if you want to distribute that, you could. That's okay. I'm just going to leave it like that. But this, we're not going to multiply this by itself 6 times. We're just going to let it be. Remember, this represents the slope of the tangent line, or in other cases, instantaneous velocity or something else. But it's always a rate of change. Okay? This derivative, we call it the first derivative, is always a rate of change. Okay? Alright, so that's it. Alright? Again, this is the chain rule that we just dealt with, part 1 of the chain rule. And I just wanted to get you familiar with some of the problems. We know that they got a little more advanced as we went along, and they're going to be even more advanced in the next lesson. So Thank you so much for your time. I appreciate every one of you, and hopefully every one of you will have a very nice day. Signing off is KP the Math G. Have a great day.